Hello, everyone. I want to thank you for joining us for today's Safety and Health webcast. I want to let you know as you file in that you are in the right place. We're going to get things started in about 1 minute. Once again, we welcome you to today's Safety and Health webcast sponsored by MSA Safety. Just want to say we're going to be starting in about 30 seconds from now as everyone files in. So thank you, and we'll be getting going in just a minute. Hi, everyone, and welcome to today's Safety and Health webcast. What the updated Z359.14 standard means for self-retracting lifelines, sponsored by MSA Safety. My name is Kevin Drewley. I'm an associate editor with Safety and Health magazine, and I will be moderating today's session. Thanks for joining us. We hope you all are safe and well amid the ongoing COVID-19 pandemic. In a few minutes, we'll start the presentation, but first I want to go over some preliminary items. The views of today's speakers and organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication doesn't mean the council or magazine endorses those items. At the end of today's webcast, we'll conduct a question and answer session. To ask a question, simply click the Q&A button at the bottom of your screen, type your question, and click the send button. Feel free to ask your question at any time during the presentation. You don't have to wait for a question and answer session to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we might not get to every question. Any unanswered questions will be forwarded along to today's speaker. At the end of the webcast, you'll be asked to complete a brief evaluation survey that will appear on a separate screen. We'll let you know more about that after the presentation. This webcast is archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, go to safetyandhealthmagazine.com/events. You may also receive a link in a post-event email. With that, let's go ahead and introduce today's speaker. Speaker today is Rob Willis, Product Group Manager at MSA Safety. Rob has worked in the fall protection industry for more than 15 years while attending ANSI ISEA fall protection meetings for the past decade and contributing to multiple standards. A mechanical engineer with a Master of Business Administration from the University of Pittsburgh, Rob has spent most of his career working in new product development, designing fall protection personal protective equipment. He has developed all major parts of a fall protection system. Rob, we thank you for being here today. Whenever you're ready, go ahead and take it away.
All right, thank you, Kevin. Good morning, good afternoon, everyone. I wanted to walk everyone through from an end user's perspective, from a site safety manager's perspective, what has changed around .14 that will have the most impact to your day-to-day. So without further ado, here is the agenda for today. I'd like to review a lot of the big changes are going to be around classification of SRDs. I'll hit on the major changes to labels and manuals, things you should be looking for. There's a new safety card included from the standard on certain types of products. And then there's a few things behind the scenes related to the design, the testmanship of the products that I think are interesting for you to know, but again, really won't change how you do product selection. So let's just jump right into this and get into the types and classifications of SRDs. So a few things on terminology. Yes, ANSI does at the highest level describe these devices as SRDs, self-retracting devices. These would be the 30, 50 foot, 6 foot units. They all are under the umbrella of SRD. The previous version of .14, this is the one that you've been working with for the past 6 years, had 3 types of PFLs. You may not have even have known that there were types of PFLs, or sorry, types of SRDs. And honestly, that's okay. I will explain the relevance of types to you here at the end. But just so we're all speaking the same language, let's go through this. Again, the previous version had SRL, which was a standard overhead SRL, self-retracting lifeline or self-retracting lanyard. SRL-LE. This was the introduction of the leading edge rated products, and SRL-R. This was, again, a standard SRL, overhead only type of mounting with a rescue function. And these types of SRDs were in there since the 2012 version. Now, in the recent release of 2021, types have been recreated. You've got 3 again, but we're trying to modernize the types. So now you just have a generic SRL. No longer is it overhead only. This is just I'll call it a large device. So something that you wouldn't wear on your back, 20, 30, 50 feet in length, something like that. That's an SRL. The newly created SRL-P is the personal PFL, personal fall limiter. That's the smaller devices that you wear on your back. There was an appreciation from ANSI that, again, about 10 years ago, you really saw the proliferation, the growth of the PFL as it replaced the 6-foot standard shock absorbing lanyard. And so it was decided that we needed to create a type of SRL to describe the small personal fall limiter for reasons which I'll get into. And then finally, the rescue SRL stayed the same. So, and the key takeaways on the next slide, types are important to know and to understand, but they're really relevant for the manufacturing community because if you look at .14 in detail, these types of SRLs give guidance to the manufacturer on how to design the product. Maybe there's requirements for strength, requirements for salt spray, or the type of testing you would do. So if you're a manufacturer, you're going to go to the section that says SRL-P, and it's going to say, do these things, and then these things, and then these things. So it's really a pointer or a mechanism, I'd say, for the manufacturing community to figure out how to comply with the standard. For an end user or site safety manager, it's probably going to be pretty rare to actually see the type of SRL, at least advertised or prolifically, on the product. And I apologize, we'll get some of these slides out. That's the key takeaway. Does it matter to you in general? Not really. They're groupings for the manufacturer so they know which tests and designs. If there's one slide in this whole presentation, though, that I would say is the key takeaway, something you want to digest, it's going to be the classifications of these SRDs. Again, let's start on the left-hand side and talk about where we have been. So the previous 2014 had 2 classifications, Class A and Class B. And at least in my time in fall protection, it always came across that from the end user community, hey, you would use a Class A rated device when you had short clearances. So you were looking for that 24 inches or less of max arrest distance. So again, that's not your total clearance to the ground. That just says in a fall event that it will stop the fall. The amount of line that will come out of the unit will be 24 inches or less. Class B was a instance where you would have up to 54 inches. Now, I didn't put all the detail on these slides. When you have a Class A, you have higher force requirements because that's how you do it in a shorter distance. You would stop the falling weight in a shorter distance with higher forces. Class B was a bit the opposite. You had more distance to stop the weight, but your forces would be also lower to accommodate that. So again, long story short, Class A, Class B, I think everyone thought about them in terms of overhead mounted devices. So they'd be, over your head, and you'd be making determinations on how much clearance you needed. That's how classifications were thought of, in my opinion, in the past. That's all going away in the 2021 version. You have 2 classes again in this new version, Class 1 and Class 2. These are examples of the labels that will actually be on the product as well. Class 1 means to anchor at or above the dorsal D-ring. Class 2 means anchor above or below the dorsal D-ring. That's a little confusing, I admit, without a picture, without some kind of reference. What does that really mean? So the comment at the bottom boils it down. Class 1 are now products that would be considered a standard or an overhead tie-off product. Class 2 are your leading edge. So going forward, when products are marked to the new ANSI standard, you should see now a large Class 1 or Class 2 label on the product in a very easy to find place. And class 1 means it's a standard SRL, an overhead only SRL. Class 2 means it's leading edge. So I think that's a really nice thing, because before it was pretty challenging to honestly know if you were using a leading edge product. There wasn't a standard marking from ANSI that said that's leading edge, that's not. So this was ANSI's way of giving some clear guidance on that. Now you might start to have questions about clearances and what does this mean for clearances, and we're going to get into that. Before we do though, I just want to again kind of tie it all together with some examples. So again, we'll work left to right. Let's say you have an application where you have a large 30-foot SRL, it's anchored overhead for ladder climbing. This would be considered by ANSI to be an SRL class 1. Again, SRLs can be leading edge, they can be standard overhead. The class 1 is rarely where you'll find the delineation of its overhead. In the second example, you have a back-mounted 8-foot leading edge PFL you're using for steel erection. This is the new class, new type SRL-P, and it's that leading edge class. And then finally, this would be really no change here, a rescue type of product. If you're using a tripod, something for confined space, you would have SRL-R, and again, class 1 for non-leading edge. This is a standard application. So I would anticipate those products being marked with something like that. Certainly the class is a requirement. Please jot down your questions as I go, and we will circle back to any and all of them. Key takeaway though, when selecting your SRL, determine if you need class 1 for those overhead applications or class 2 for leading edge. That's one of the real big changes here. Now, for those of you who are already kind of getting ahead of me and thinking, well, class A and class B related to my clearances, that's how I would determine clearances. I would take 24 and I'd add in the worker height and I'd add in any obstacles, all the other considerations to determine that. How do I do that now that we don't have class A and class B? So again, we'll work left to right here. 1, to reconfirm again, you will see class 1 or class 2 on the products. And now class 2 in the center. So if you have an SRL, again, those larger units, 20, 30, 50-foot blocks that are a little bit bigger. And if you have a leading edge version of it, ANSI requires that you have some form of a clearance chart and pictogram on the product. So this is the included example from the ANSI standard, where for a large leading edge SRL, you'll have the table, which gives you some reference then to the working surface. I acknowledge it's probably a bit overwhelming if you've never looked at these types of tables before. You've got all your different, X, Y's, and Z's, and you're just trying to figure out what is it that I need. Every manufacturer is allowed to come up with their own ways to show this. So there's no standardized way, but it will at least be required on the product. And the thought here is, again, to take away the math though. So instead of saying, well, my SRL should decelerate the distance in 24, 54 inches, and then I got to add in these other things and I come up with a total thing, that is all going away. These charts, while not perfect, are going in the right direction, that really you should be looking for one number. And that's what that kind of a Z lettering is showing there, that the distance from the working surface to the ground or to the next obstacle. So that once you get familiar with these charts, once you learn to look at them a little bit better, you're just going to be looking for one number. And that's where you can tell your team, your crew, hey, we need 19 feet in this application. We need 25 or we need 16. It's going to depend on some of the parameters of the chart. So large SRLs, class 2, need to have these types of included charts. Similarly, the personal ones, those mini PFLs, personal fall limiters, small blocks, they also need to have some required labels on them when they're leading edge. Again, there's no required standardization. And what I anticipate seeing is something similar to what you see in the screen here, where it's kind of the worker showing different tie-off points and those numbers on the grid representing the clearance from the working surface to the ground. The reason that they broke up 2 examples, because really they're trying to accomplish the same thing, is just an acknowledgement that the smaller blocks have smaller real estate. There's not as much space to put really in-depth charts. And so you're allowed to do maybe more simple diagrams for the SRL-Ps, the smaller units. I think it also makes sense because when you think about it, for the small units, those 6 to 8 footers, you will have less like swing fall, less offset, because it's just really limited. You get massive swing falls, or you can get massive swing falls when you use the larger blocks. Therefore, you get a little bit more complicated charts that say if you're offset 5, 10, 15, 20 feet, this is what you need to be thinking about. So that's another reason for kind of the breakout is fundamentally being different sizes will create 2 different types of charts. So yeah, these are the big things that these will be on the products. They're trying to drive end user behavior to think about it in terms of one number, trying to take away the need to do the math on the job site, and trying to really call out leading edge versus kind of that standard with that class 1, class 2. Let me just summarize that again. Class A, class B, no longer applicable. To determine the clearances, though, you need to refer to these charts that are provided by the manufacturer and now will be required on the leading edge products. Spend just a minute here talking about the new warning card requirement. So I'm just going to go ahead and read it to explain it. So the card in that orangish yellow color is required for all manufacturers to include when it is a class 2, a leading edge product. So warning. This class 2 self-retracting device, when attached to a foot level anchorage, poses significant risk of injury. The user, the competent person, and/or qualified person should all acknowledge that normal use of this device may not prevent a serious injury. Failure to follow all manufacturer's instructions and warnings may result in serious injury or death. So what's the intent of this card? What is ANSI trying to teach us? The intent is to remind everyone 2 things: that leading edge products are not, invincible. They have limitations, and they must be used in accordance with manufacturer's instructions. My personal opinion is that leading edge products are durable, they're robust. If I were to choose PP, I would personally choose leading edge products because I've seen the tests, I've seen what they're able to go through. But it is true, and we do need to acknowledge that you can't just take the mindset of, oh, all right, good, they're in a leading edge SRL, PFL, we're covered, we're good. They can tie off at their foot level. It doesn't matter what substrate they may fall over. It doesn't matter what the working surface is made of. Those are all untrue. And sometimes there's lots of clearances required in these situations. So the intent of the card is just to make us double check, rethink about the limitations of the products we're using. The other comment here is the card's intending to emphasize the hierarchy of controls and continuing to utilize overhead anchor systems when possible. And that makes sense. I'm sure everyone on this call understands that if you have the opportunity to anchor overhead, always do that. Even if you're using a leading edge rated product, anchor them overhead, you have a much better possibility of lower clearance requirements, reducing the risk of injury. It's just always best practice to try to anchor overhead when you can, no matter what the product you're using. I'd like to spend just a few minutes on leading edge, on class 2, just to give maybe some perspective. It's a good refresher for everyone, I think. So what does ANSI require from a design perspective when it comes to leading edge? So ANSI wants the energy absorption system to be located near the body. In these 2 examples you'll see on the left is those smaller personal PFLs, SRL-Ps, and the black case behind the product is the energy absorption system. So I think many people have seen products from manufacturers that have the pin type of connection that connects to the harness. When you're doing that, you're placing more often than not the energy absorption system on the person. Likewise, on the right, if you're using a larger SRL, you'll see that black kind of box shape down by the snap hook. That's the energy absorption system on that. That obviously attaches to the end user, keeping it closer to them. But why does this matter? What's going on here? Well, energy absorption capacity is limited over an edge. Let's work left to right again. So this, you'll see in the image on the left, this is a standard SRL with the energy absorption element of it inside the unit. So in this case, you can see they don't have it anchored overhead, they have it down at foot level. In this scenario, the end user has fallen over the side, and when that line constituent, that cable, that web, that rope, whatever it is, goes over the edge, what we're finding through the physics of it is that you create a pinch point. That material typically grabs and bites at the edge. And when you do that, you are not allowing the energy absorption system to kind of flow through the line. So if you think about, I don't know, tug of war or something like that, and you're trying to pull that line or move the line up and over, it's getting stuck at that edge. And when you do that, when it gets stuck, you take the energy absorption out of the system. And that's what's being shown pictorially in the image on the right, that unfortunately the line can break. And that's the big risk of using a non-leading edge rated product at foot level, at a level that can cause the line to touch the edge in a free fall event. So how is the industry progressing to improve safety? That's where it comes back to putting the energy absorption on the person. So in that same exact scenario, you got the SRL down low, an unfortunate fall event occurs, you're still going to probably get that pinch point at the edge. But now it doesn't matter what happens from the edge of the building to the person, because they've got that energy absorber that can deploy, absorb the forces, certainly hopefully able to arrest the fall. And that's why, from a design perspective, ANSI is asking the manufacturers to put that energy absorption element on the person, so that when you see the physics of what's going on here, when that line touches that edge, you know you're in your best case scenario where you're covered from that edge down. How are leading edge products tested? Again, want to give some clarity to the ANSI standard about what it does and honestly what's not covered, so that you can make informed decisions. There's really two types of tests over one specific material right now in the ANSI standard. So the images we're looking at are overhead. Imagine you're, bird's eye view looking down on a building. That's the perspective. It's not from the side, it's overhead looking down. What you've got on the left is what we call the perpendicular drop. So imagine this scenario that SRL is sitting on the ground. It's on the ground, and the manufacturer has to pull the line out with the test mass past the edge and release the weight. It's typically at a height that is equivalent to about D-ring level, so about 5 feet off the ground. And if you can imagine, weight falls 5 feet. Honestly, it falls a couple feet more before you get the unit to lock up and pay out. So you're looking at typically, I'd say 7 to 8 feet of free fall in these scenarios for this test. There are force requirements that come out of that, and static test requirements that come out of it. So there's a lot that goes on from a manufacturing perspective, but at a high level, you pull the line out, up into the air and out over the edge. The product is tested on a steel edge with a radius of 0.005, so 0.005 of an inch. That is very sharp. I will make no bones about it. That is a sharp steel edge. However, it's not concrete, it's not decking, it's not wood or rebar or many of the other materials you may see out in the real world. And that's where we want to have some clarity around what is currently covered in the ANSI standard. There is also offset drops we have to do. It's a realization that workers aren't going to be able to just walk straight out in a perfect line. You're going to have that offset, that swing fall event. And the standard requires a 5-foot offset. As you can imagine, it does depend on the line material you use, but typically you do see that swing event as the line will kind of cut across the steel edge. It's interesting to note that really there's two types of, I'll call them failure modes of these devices that manufacturers design around. You have just tensile strength. That stuff needs to be very stout and durable, but you also have to have a cutting resistance to it, because as you can see, you slide across the steel edge. And so I'd say those are the two parameters that manufacturers are continually trying to improve upon and design into the products. So perpendicular, offset, 5 feet. That's what is happening in the test today. We also are required, I should say, to test in many conditions. So you do it in ambient, cold conditions, hot conditions, wet conditions. So it is a good simulation of at least many environments, out in the real world. So a couple of things that I think you might find interesting, classifications, behind the scenes stuff. So these would be things that, may not really change your behavior or how you choose a product, but I think it will give you some peace of mind to know that, again, ANSI is always developing the best standards, the most rigorous standards, really trying to drive progress when it comes to PPE design. These are things that, again, most people won't notice, but I think you can take to heart that it's good to know it's being done. The first bullet point is that .14 actually now uses a 1-to-1 test mass to end user correlation. For those of you who are still kind of picking this up or learning it, OSHA, if we start with OSHA, says that a manufacturer can develop a piece of PPE using a 100-pound solid mass of steel. That 100 pounds allows the manufacturer to put on their product that an end user can be 220 pounds with clothing and tools and everything. So test with 100 pounds steel will represent 220 pounds of human body with tools and everything like that. OSHA allows you to scale that up, and that's how you'll see weights beyond 220 up to 400 or 500 pounds. You can scale that up. ANSI and the previous revision used a 1 to 1.1, so it was close. It was 282 pounds to represent a 310 pounds. For clarity, to improve, again, we felt overall safety margins, it was agreed upon that we should just go 1-to-1. And so now when those tests you saw on the previous slide with that overhead view, we are testing a 310 pound mass over the edge. I do think it's important to take to heart those capacities, though, when you are looking at leading edge products. If you are over 310 pounds with the tools and clothing and all the gear that you are carrying up and down, if you think you're over that in a leading edge scenario, we gotta be very careful, because these are rated to 310 pounds, tested with 310 pounds, but no more. Manufacturers can go beyond that, but they would not be meeting the parameters of ANSI. That would be done through other means. So either way, I think it's a really good thing, though, that they've really bumped up the safety. Another behind the scenes piece is that SRL-Ps class 1 have to be able to absorb 6 feet of free fall and limit forces to 1,800 pounds. So what does that mean? Again, the proliferation of the small mini PFL is replacing the 6-foot energy absorbing lanyard. It was acknowledged from the ANSI committee that when people are using those small PFLs, most likely it's not being anchored overhead all the time. You're having to anchor at shoulder, at waist level, at things like that. And so ANSI is saying that if you have an overhead small PFL, you still need to try to limit that limit the anchor points to overhead. They're not giving any give there, but manufacturers have to sort of account for some misuse in there, and we need to be able to absorb 6 feet of free fall for a class 1 device. Now, again, you can make a leading edge PFL small personal one class 2, but that's a different set of criteria, different set of testing and markings. But just wanted everyone to know that, again, behind the scenes, I think you'll see some changes to designs to meet that requirement. Third one is new strength tests for integrated brackets on SRLPs and internal mechanisms. Just 2 things that come to mind. The picture on the right is showing, many of you probably have products where you have the pin connection, that bracket connection to, again, attach the PFLs, the small blocks to your harness. There was really no guidance from ANSI prior to this revision on how do you test those. They had some high-level strength requirements, but it didn't really get into the detail that this version does. And that's what this picture is showing. manufacturers have to test the diagonals, across, up and down. So they're really, pressing the manufacturing community to understand those bracket type of connection systems to make sure that there is robustness and factors of safety and all the different orientations that you could have. A few other small things, new tests for strength where we have to lock pawls up against we have to lock the mechanism up and do certain strength tests to them. Again, things that really won't change what you're doing day to day, but it's good to see that ANSI is really pushing the teams to come up with more durable products. And even misuse tests, things like, again, when you have a twin SRLP, those small ones, I think every manufacturer that I'm aware of says you're not supposed to ever keep both of your snap hooks connected at the same time. However, ANSI says, well, let's just test, see what happens to make sure manufacturers do their diligence. Doesn't mean you're allowed to do it, but it is, again, reinforcing with the manufacturing community that the real world, you're going to get this stuff from time to time. And let's just make sure these products are as safe as we can make them. So again, twin level tie-offs where you have to test the entire unit from snap hook to snap hook. It's a big change in standards for the manufacturing community. It's pretty big. There's a lot of work being done to do some design changes across the board at the end of the day. The future of ANSI, where do we go next? So the standard just got released. It takes easily 4 to 5 years to get these through a design cycle. It's a huge team that works on it. But I see the continuation of looking at, new edge materials, for example. So appreciation that we need standardization for concrete decking, things that I mentioned before as a way to test against it. But, we're really going to just be reopening this up for the first time. So if you're interested, if your organization has always been trying to get involved a little bit more, ANSI's voluntary, meets twice a year for 359, open to anyone. And, if you are passionate about safety, if you think you can bring a unique perspective, we can never have enough end user perspectives, to be honest. Always looking for that feedback of this happens in the real world. You guys should be thinking about it in terms of X, Y, and Z. So I have to put a little plug in there that if you're interested, please reach out. Get you involved. We can always use some new opinions and perspectives. And so that wraps up my formal presentation part of this. Unless there's any questions or commentary from Kevin or the team, I'm ready to jump into some Q&A.
Well, no, excellent. Great job, Rob. Thank you for your insights and your expertise. Before we do start the Q&A, just want to remind everyone of the evaluation survey that we're asking you to complete. The survey will open in a different screen after this presentation. Your input is important because it'll help us improve future webcasts. We appreciate you taking the extra time to offer your feedback. Once again, a reminder, if you wish to ask a question of Rob, simply click the Q&A button at the bottom of your screen, type your question, and click the send button. And we now will go ahead and get started with those.